It's right there. Will you grab it? And then you need a purple sheet too if you don't have that.
Let me grab a pencil. You got an extra pencil?
Can you just use a pen?
Are you good, dog?
I'm so good. I don't have it. Oh, so hard. Does anyone have a pencil he can use? Come on. Oh, Glenn. Look at Glenn.
I'm finna die for it.
Okay. Okay, we gotta start. So, look at your review. Okay, you have your test the next 2 days. Tomorrow is with the calculator. So we're gonna start doing some of the calculator questions to make sure that you remember how to do it. Okay? So your test on Thursday is your test on Thursdays with, Friday is without. Okay, also let me remind you that on Friday your review is due as well.
Oh yeah, is it a quiz grade?
It is, yep. It is a quiz grade, okay? So go ahead and turn to the last page.
Like the very back?
Yep. Yeah, the last page are like your calculator questions. Yep.
My study buddy.
Okay.
Yeah, 369. I like 369.
Okay. Focus. Okay, so all of these last questions are calculator questions. Look at number 18. Go ahead and type it in.
I'm 18.
Okay, it's the second to last page. It's where the calculator section starts. Okay. So go ahead and type it in. You remember how to pull up the little fraction thing? Hopefully, please. Alpha y equals good. Okay, so I'm going to do alpha y equals 60 divided by x plus 2. 60 divided by x plus 2.
What does ton mean?
Time, units, noun. It's when you're interpreting the meaning. So we'll go over it. Okay, so first thing it asks me to find is p of 8. Is that a derivative?
No.
No, go into your table. Go down. Someone messed up my table.
Oh no.
What's wrong with it? Why does it? Oh, there it is. Okay, 8 is 6.
Which table?
Second graph.
8 is 6. So table starts at 8? I feel like I'm Gucci.
Okay. So this is the table in the calculator. I'm just looking for the y value. Okay, then it says interpret the meaning. Okay, well let's see what P stands for. The amount of radioactive matter in a petri dish measured in grams is a function of time and hours. So ton stands for time, units, noun. So you would say at time, T equals 8 hours. There are 6 grams of radioactive whatever material in the petri dish. No cocaine.
That gas.
In the dish. Okay? Now, obviously, you could try to shorten that up and say, you know, at 8 hours, there's 6 grams of material if you want. Okay, but that's what ton stands for, is time, units, and noun. So, my time is 8 hours. My unit is 6 grams. My noun is radioactive material in the dish. Now, when I find P prime, that tells me how fast that's changing. So, second trace in the graph. dy dx is option number 6. Okay, also my graph is zoomed in, but remember, as long as I can see 3, it really doesn't matter. You can fix it if you want to, but I'm not going to. Okay, so I want the derivative at 3. Even though I can't see the picture, I know I can see 3 on the x-axis, so I know I'm going to be able to find it.
Negative 2.4.
Good. Now, why can't I see my y value? Well, it's way up at 12, right? But that's okay.
That's too far.
Okay? So I'm going to put p prime at 3 equals negative 2.4. Now, if my original thing was in grams, what is its slope in? Grams per hour. Okay, because you just divide your rise over run. So my rise was measured in grams, my y value, my run was measured in hours. Now if it's negative, what's happening to the amount of crap in the Petri dish? It's going up or down? Down. So I would say at T equals 3 hours, amount of material is decreasing at 2.4 grams per hour. Now, if I say the word decreasing, should I also put a negative here? No. Okay. Yeah, that's a double negative. So if you say it's decreasing at 2.4 grams per hour, that's good enough. You're done. Okay, so that's what interpret means. Okay, the next one, number 19, I'm not going to do it for you, but what's the difference between acceleration at 3 and average acceleration over 0 to 3?
A rock.
Which one's A rock? A or B? Okay, this one is A rock, so you'd be doing V of 3 minus V of 0 over 3 minus 0. What would I be doing in part A, though? Taking the derivative. Good. Derivative at T equals 3. Do y'all want to go ahead and do it, or y'all good? Okay, so go ahead and type it into your y equals. Yes, ma'am.
V says the average acceleration, but we have to use the velocity.
Yes, somebody else was asking me that in the other class. So remember, if you're doing average rate of change of velocity, you're doing the slope formula with velocity. You're not doing the slope formula of acceleration. That would give you the slope of acceleration. That's not what you want. Okay? Also, you can think about units. If this is velocity is meters per second and I divide by seconds, that gives me meters per second squared. Is that an acceleration? Yes. What if I put acceleration here? It would be meters per second cubed. You don't want that. Okay? So it's 7 minus 1.01 up to the power of negative x squared. Okay, just like that. Oh, yeah, okay. Then from there, I want the derivative, so let's practice it the other way. Regular screen, second quit. Remember, derivative is math 8. Math 8. So I type it in. Math 8 is n derive. Then remember, it's d dx of alpha trace y1 at 3. And you would type it in just like that. So my derivative comes out to be v prime of 3 equals 0.0545. Now look at your answer choices. Which one's closest? Good job. Okay, then A rock. Open up your low fraction bar. Alpha y equals n over d. Alpha trace y1 at 3 minus alpha trace y1 at 0 over 3 minus 0. Could you just put over 3? Sure, if you want to. Same thing.
Miss, I like your boots.
Thanks.
Is those Uggs?
No, they're like Target Uggs. They're like fake off-brand Uggs.
Are they bear paws?
Honestly, I couldn't tell you. I don't know. If I knew, I'd tell you.
They're Target.
They're Target, though, yeah.
Target Uggs.
Good?
Yeah.
Perfect.
Then you like this.
Okay, then the last thing you really need to know how to do for your test tomorrow, so you need to know how to do graphs of f and f prime, and then graphs of velocity. So let's take a look at our next one. We have the position. We need to know the graph of velocity. Well, then what do we need to do? Take the derivative. Now, some of you guys are not so good with derivatives. What rule does that need? If I want to take the derivative of e to the sine t, it's not product rule,
Chain?
chain rule. Now, here's the difference. What if it was this?
Then you use product rule.
That would be a product rule.
Yeah.
But this is a chain rule because your sine is plugged into the exponent of your e. One function is inside the other. So velocity equals x prime of t, the derivative. Now we're going to take it. E to the sine t, the derivative is e to the sine t again, multiplied by the derivative of sine t, which is what?
Cosine.
Good.
Ooh, I'm smart.
Okay, then from there, what are you going to do? You're going to use your calculator to look at the graph and then sketch it on your paper. Okay, so I'm going into y equals here. Going to type that guy in. So e to the power of sine x, close the parentheses, times cosine x.
Wait, how'd you get D?
If you look on the ln button, just hit second ln and e will pop up. Okay? Now, do I want to look at it on the whole number line? Where do I want to look at it at? 0 to 2 pi. So remember, the window is where you adjust that. So once I type in my derivative, I'm going to push window, I'm going to go 0 to 2 pi. Just like that. And then I'm going to hit graph, I'm going to put it on my paper. So boom, here's the picture. Allergic to math? Oh. Okay, once you sketch your graph, how many times does the particle change direction? What am I looking for in the graph? Crosses the x-axis. How many times does that happen?
2.
Twice.
2.
2 times. And I'm going to put through x-axis because velocity changes sign. Okay, remember that's what I'm looking for. Now the next question says, when is the particle traveling to the left? Well, what am I looking for the particle to travel to the left? Velocity has to be what? Negative, which means below. So I want this little chunk of the graph right here. Now, in order for me to list that interval, I need to know these values. Remember how to find them?
You gotta go graph. Intersect?
Yep, second trace. Now, I don't want to push intersect because I don't have 2 equations typed in. I want the 0. And then remember, there's 2 ways for you to do it. You can click your little cursor around, or you can pick 2 whole numbers that falls between. So for example, for this one, what is that cross between 1 and 2? So I'm going to do 1 as my left bound, 2 as my right bound. Or you can click your little arrow over, okay, and that's allowed as well.
What if you did both? Like 1 and then move the other one?
If you encompass 2, it's going to give you an error because it's not going to know which one you want. So if you're going to type in, you need to make sure don't trap both x-intercepts or else it's going to give you an error. So the first one is 1.5707. Okay, then second trace, I want the second one. I'll do this one with the little arrows just so you can see both. But it looks like it happens around 5, so if I was going to do left and right, I could pick 4 and 6. Okay, but let's pretend like you don't know how to do that. You can just arrow over to where you're on the left side, then arrow over to where you're finally on the right side. Yeah, that's why I don't really like that way as much, but it still works. Okay, then it'll show you the 2 little lines. I see it crosses between them, so I hit enter through guess. 4 point.
7, 1, 2, 3.
Good. So that means that my graph, my particle, was traveling to the left from 1.5707 to 4.7123. If it said to justify, what would you say? Because v of t less than 0. Okay, we're going to skip ahead to part D. We'll come back to part C. How do I find acceleration if this is the graph of velocity? Take the derivative. Very good. So if I want the derivative at 3, remember how to do it. You're going to hit second trace. Go down to your dy dx option, which is number 6 if you're looking at the graph. And then I want the acceleration at, type in the number 3. And then push enter. Okay, on the old calculators you only see dy dx, but on the new ones just make sure you're looking at the right thing. dy dx is 0.9661. Okay? So a of 3 equals v prime at 3, which is 0.9661. And then what'd you say, Yoshi? I didn't hear you.
Oh, can you ask me what the answer is?
Oh, okay. Cool.
And I'll let you know that he just forgot the units, but his answer was correct.
Good. I love that. Okay, how do you find a min and a max on the graph? You look at the,
Min and max.
okay, you have to look for where it changes sign, because remember, what is the min and max here? Those are points of inflection for the graph of position, right? So you have to be careful about that. So, when I'm looking at this one, what kind is it? A min or max? It goes from above positive to below negative. Think about, my graph went from a positive slope to a negative slope. What is it?
That's max.
That's a max. Okay, and then for my second one over here, it changes from negative to positive. That makes it a min. Okay? Now, the last thing I want to remind you of is that when you are dealing with a particle motion question, they're not going to say absolute. Did they say relative? Then that means absolute, because you have endpoints. So be very careful. Okay, these are both absolute, even though they didn't say so, because you're on 0 to 2 pi. Okay, if they say relative, you're just looking for a sign change. But if it doesn't say relative, you need absolute. So I'm going to make a chart. What goes in my chart? Okay, the original time values, which are what? 0 and 2 pi. And then what are my two critical numbers I just pulled? And 4.7123. Okay, and then when I plug in a candidate's chart, you're looking for the biggest y value and the smallest y value. You're plugging back into the original. So can I use what's typed into my calculator as it is? Is that the original? What was the original?
E to the sine.
Just e to the sine x. So I have to go back to my position, e to the sine x. And then I'm plugging into that. Okay? Then remember, if I look at my chart, none of these numbers except 0 are going to be in there because they're all decimals. But that's okay. You can second quit. Alpha trace y1 at 0. Alpha trace y1 at 1.5707. Alpha trace y1 at 4.7123. Oops. Don't forget your little parentheses. And then alpha trace y1 at 2 pi. Okay? And then look at your values. Who's the biggest?
1.47.
2.7. And then who's the smallest? 0.36. Yeah? So this one is 1, 2.7182. Yeah, I will. 3678. Now, look at the question. It says, when does it have a min and max? So I would say my absolute max occurs at 2.7. It occurs at time 1.5707 seconds. So min is 0.3678 at t equals 4.7123. Max is 2.7182. It occurs at t equals 1.5707. Okay? And then if I only go to 2 decimals, am I going to get full credit? No. Don't do that. Okay? All right. So, do you have any questions, or do you want me to pick some questions?
Pick questions.
My calculator, I said the calculator,
Check your y equals. Did you remember to take the cosine out?
yeah, I did.
Okay, you want to just glance through it and see what you need help with? Or I'll just pick. Okay, you're in degree mode. And then they should all come out. Because for your chart, you're always plugging back into the original. That's why. And I had the derivative in the calculator originally. Sure. Okay, turn to number 11. Oh, also guys, number 21. Okay, the very last question. I'll send you a video of this. This one's kind of hard. There's not one this hard on your thing.
Tomorrow this time?
No, it's due on Friday.
How are we gonna be?
Okay, number 11.
It's on the first page.
On the first page? Oh, okay. Actually, this is a great one. There's one just like number 11 on your test. Okay, so number 11, take a look at it. What rule do I need to take the derivative? Product rule. You will also do chain rule within your product rule. So my u is going to be e to the 8x. My v is a 2x plus 1. This is the very front page, y'all. I pulled these off of an AP test. That's why they're numbered weird. This is very first page, number 11. Very first page, number 11. Okay, so if u is e to the 8x, what's u prime? E to the 8x times what? 8, because of y? Chain rule, right? Okay, then from there, what's v prime? Derivative of 2x plus 1 is 2. Then for my product rule, I add the products together. So f prime of x is e to the 8x times 2 plus 8e to the 8x times 2x plus 1. Everybody good with that so far? Okay, let's look for a common term. What do they both have? E to the 8x. So I'm going to take my e to the 8x out. Okay, what's left over from the first term? 2 plus. And then what's left over from here? An 8 and a 2x plus 1, right? So I need to distribute there. So I'm going to write it in 2 steps. You may not have to do this. That's fine. Okay, but I'd have my 8 and my 2x plus 1 left over. Then I'll distribute. So 8 times 2x is how many in here? 16x. And then 8 times 1 is 8 plus 2 more is 10. Can anything pull out of that?
2.
Can take out a 2. So a 2 pulls out. That leaves me with an 8x plus 5. And then what did I already have in the front? E to the 8x. So now look at those answer choices. Okay, order doesn't matter, but it needs to have an e to the 8x, a 2, and an 8x plus 5. Which one will it be? Get it? B.
Oh my god, can I go to sleep now?
No, you were already taking a nap just 5 seconds ago.
No, I didn't. I closed my eyes and I took a large.
Okay, pop quiz. What are you doing on this one? What rule?
17.
Quotient rule. You should know that. Look at number 1. What rule are you doing?
Which one?
First one.
Oh,
Chain rule. Do we need to do one of those?
No, don't move it. Quotation.
Okay. Alright, remember you split it up into a high and a ho.
Yeah, then you divide it
Oh,
by.
never mind. Let's do the chain rule one.
What?
Okay. Sure. I'm already too far in. We gotta finish it now. Okay, high is 2x plus 3. What's d high?
2.
2. Ho is 3x plus 2. What's d ho?
2. 3.
3. And then remember, it's ho d high. Put them in order. Ho d high is 3x plus 2 times 2 minus high d ho is 2x plus 3 times 3. All over ho square, 3x plus 2 squared. Then from there, you need to work that top out to make it look like one of the answers. So from here, what's 2 times 3x?
6x.
Plus
4.
4. Next term, what's 3 times 2x?
6x.
But it's minus. And then 3 times 3 is, but it's minus. Okay, then look at your answers. Which one do we want? 6x is crossed out. 4 minus 9 is. There's a correct answer on there after all. Okay, good? Okay, do we really need to do the first one?
Yes.
Scrubs.
Yeah, exactly.
Okay, look at it.
No, wait. No, we don't. Let's do this.
It'll be real quick. Okay, take the 4, times it down to the front. Okay, if it was to the 4, what power is it to now? The third. Then you times by the derivative of the core. 3x squared. Okay, make sure in your first step of chain rule, that middle should stay the same. Okay? Then from there, 4 times 3x squared is, so it'd be that one.
So that's.
Okay, what's wrong with C? They forgot the cubed. Good. Okay? Okay, there's one very similar to number 5. What's the derivative of tan 4x? Secant squared 4x, that's it? Times 4. And then what do I do after that? 4 secant squared. Good. So it'd be that one.
Oh, let me pick one. I want to pick one.
Okay. Can you try to pick a hard one?
Number 9. A ski on both sides like
14? You just picked that because it's long. That's not hard.
You just started grab. And you got the number 9.
Yeah, number 9 over here.
Okay, we'll do some in number 9. Turn to number 9.
I'll put my car on.
9 with the table. Okay, now look. The more talking, we're not going to get through stuff. So shh, shh, shh.
Number E.
Okay, let's start with, we'll do E. Let's start with the easier one though. Let's do letter B. Okay, look at it. You have h of x, you want h prime of 2. That means I'm taking the derivative. What rule are we using? Product rule. So my u is 2x cubed. My v is f of x. What is u prime?
6x
squared.
Squared. And v prime is? F prime of x. Remember, when you take the derivative of an f, it's just f prime. Okay? Then from there, h prime of x is going to be a cross product of my diagonals. So I'll do 2x cubed times f prime plus, product rule plus in the middle, and then 6x squared f of x. Then from there, what do I want the derivative at? H prime of 2. So I'm going to take each one of these x's, I'm going to replace it with a 2. Now, where am I going to find f of 2 and f prime of 2 from the chart? Okay? So from here, let's plug our 2 into this first term. What's 2 cubed? 8 times 2? 16 times. Next, I want f prime of 2. Use your chart. F prime of 2 is 4. Plus 6 times 2 squared. What's 2 squared? Times 6 is 24. And then f of 2 gives me negative 2. So 16 times 4 is 64.
minus 48.
Minus 48. Now, let me also say, if this was the real AP test, you could leave it like that. You don't have to subtract if you don't want to. Now, if it's multiple choice, you'll have to.
16.
It'd be 16 left over, yeah. Good?
Wait. Good job, Yoshi.
Good job, Yoshi. I'm so proud of you.
Thank you.
Okay, let's do letter F.
Wait, I'm lost.
Okay?
Wait, I'm lost.
This is H. Now, actually, let me fix my labeling mistake here. Okay, purple is H prime of X, blue is H prime of 2. So remember, you should have those labeled.
That's why. I didn't
Yeah, I started plugging in numbers. So I took the 2 from here, and I just started popping it into each of those X's.
Can I go back?
No. Okay, look at letter F. F of G of X. Product, this one, we're skipping to here.
Derivative of f of g of x.
Is it product rule?
No.
Chain rule. Good. Okay, that's a chain rule. So remember, the derivative of the outside F.
If I beat up,
Okay, the derivative of F is F prime. Remember that G of X in the middle stays the same, but then I multiply by its derivative at the back. G prime of X. Now, let's say that you wanted to do chain rule one more time. What's in the middle of G prime? Just an X. What's the derivative of just an X? 1. So it doesn't matter, you can put it or not, nobody cares. Okay, from there, what are we plugging in? 5. So then I want F prime of G of 5 times G prime of 5. And then obviously you're using your table at that point. What is G of 5 in the center?
3.
Okay, so I want F prime of 3 times G prime of 5. F prime of 3 is negative 1, right? Okay, and then 5 for G prime is 3. So it'd be negative 3 overall. Make sense?
No.
Okay, let's do letter E, since that was requested.
Number E.
Letter E. So it's f of x
Squared.
squared. Very good. Okay, so what do I do first? I take my 2, I times it down to the front.
So 2f of x.
And now f of x is to what power?
None.
The 1. So you can put the 1 or not, but remember, I bring the 2 down and then I reduce the degree. Now, f of x in the middle stays the same, but then I multiply by f prime of x. If I wanted to go one layer deeper, it's an x in the middle. What's the derivative of x?
Just for one.
Times 1. Okay, from there, we're plugging in 5. So I want 2 times f of 5 to the 1, nobody cares,
F of 5.
and then times f prime of 5.
Well, let me do this one for you. F prime of 5 is, no, F of 5 is 5. Times 2 is 10. Times F prime of 5.
Times 2, times 2.
So,
1
Equals
20.
That will equal 20, man.
Well, bad.
That will equal 20.
I bet you said,
God, man.
yeah. Okay, good? Alright, now look at letter G. I'm going to rewrite it for you. Okay, that's f of 2x plus 1. And then remember, when they tuck the exponent in like that, it means the whole thing is squared. So how many layers does that chain rule have? Only 2?
3.
3. Has the squared as the outside layer, then the f, then the 2x plus 1. Let's do it. So this is a double chain rule.
Double chain rule.
Yes. Okay, so outside layer is the squared. I take the 2, I times it down to the front.
So it's going to be 2.
What's the new power on f of 2x plus 1?
1.
To the 1. Okay, times by. Middle layer is f of 2x plus 1. What's the derivative of f? F prime, 2x plus 1 stays the same. Then what's the derivative of 2x plus 1?
Times 2.
Times 2. So that's a double because you had 3 layers. Yes, ma'am?
For B, which one is the inside of all of them?
Okay, that's a great question. So the insidest, we'll say, is 2x plus 1. Then f, and then all of that is squared. That's the outside.
Right.
But the way that they write it, they're going to take the 2 and put it right there. So that's why I rewrote it, was to show all of this is squared. Even though they write it like that, that's just the notation.
Yeah, but is the middle the f of the 2x of 1? Plus 1?
So the inside of the squared is all of the f of 2x plus 1. And then inside f is only the 2x plus 1.
Right, so the inside is the 2x plus 1.
Yes, correct. Okay, then from there, what are we plugging in? 1. So let's just plug into the middle part here. So if I put a 1 here, what do I get in the middle? 3. What's f of 3? Okay, so that's 2 times 3. Okay, then times, plug in a 1 here, that's an f prime of 3. What's f prime of 3? F prime of 3 is negative 1. And then random times 2 at the end, and then times it all together. So 2 times 3 is 6, negative 6 times 2 is negative 12.
Open
Yes. Okay, letter H, change the x to a 1. You can't take the ln of 0, so it has to be a 1.
Hey, bro, don't touch me like that.
Okay, we still have like 10 minutes, so something else?
No, we should work on it by ourselves. Yeah.
You can do that at home. You should have already done that at home, actually.
No, miss.
That's why I gave it to you on Monday. 14? Fine, we'll do 14. The purple sheet you're supposed to watch the video for. Okay, and let me remind you guys.
Video. Ain't nobody here watched it, I promise.
Okay, then ain't nobody gonna have a review sheet to use on their test. And
Miss, you don't mess with it.
when you ask me a bunch of questions, I'm gonna say, then watch the video I sent you. Okay, look at it. This is a graph of what function? F prime of x. Okay, it says it right there. So how do I find my relative maximum? Part A, I want a relative maximum. Okay, which x-intercept? Because I see 3 of them. I need which sign change? For a max, I need it to have a positive slope to a negative slope. So it'd be at -2. So for part A, I would say x equals -2 relative max because f prime changes plus to minus. Part B, where is the function concave down and decreasing? Okay, so let's think about that now. I'm going to write concave down and decreasing. Okay, let's talk about what those things are. Now, do they want this graph to look concave down? No. They want f to be concave down. Is this f? No. How do I know concavity in the graph of f prime? Concavity is the slope. So if I want concave down, I want f prime to have a negative slope. Okay, now I also want f to be decreasing. Then where should f prime be? Negative or below the x-axis. Okay, and remember, the reason why is because this is not a graph of f. This is a graph of his little baby f prime. So where does the graph have a negative slope and it's below the x-axis? -2 to -1 and 1 to 3. So I would say from -2 to -1, union 1 to 3. Okay, because f prime of x less than 0 and f prime has a negative slope. But remember, concavity for f is f prime's slope because it's really the second derivative. Okay? Part C, I want points of inflection. Points of inflection are f double prime. What is f double prime in the graph of f prime? The slope. So look at the graph. Put x is where the slope changes. Where does the slope change? How many x's should I be placing? 3. I got 1 here. Boom. 1 here. Boom. 1 here. Boom. So I'm going to do part C in this section right here. Okay, I have points of inflection at x equals -1, 1, and 3 because f double prime, the slope of f prime graph, changes sign. Okay? Points of inflection at -1, 1, and 3 because that's where f double prime, which is the slope of this graph I'm looking at, where it changes sign. Okay, then last part, part D. Suppose a tangent line estimation was used at 2 to approximate f of 2.1. Are they asking you to do that? No, it just says, suppose somebody did that. Okay, then it says, would the tangent line be above or below? What tells you whether the tangent line is above or below? What feature of the graph? Concavity. So, at 2, look at the graph. At 2, what's the slope? Negative. That means what's the concavity? Concave? Down. And where's the tangent line on a concave down graph? Above or below are your choices?
Above.
Above. Okay, so let's write it out. Letter D. F double prime of 2 is less than 0 because f prime graph has a negative slope. So when I want f double prime, I'm looking at the slope of f prime. I see that it's negative. Now, if f double prime is negative, that means that f is concave down. And then I'm going to draw a little concave down graph. I'm going to draw a little tangent line on it wherever I want. And I'm going to notice that the tangent line is above the actual value of the graph. So, therefore, tangent line is over actual value. If the second derivative is negative, the original graph must have been concave down. That tells me my tangent line's going to cut above. What if my graph had been concave up? Where would my tangent line fall? Below. Okay? Good job. This one you get to use a calculator for as well.
Are you serious?
Number 15, yeah.
Thank you.
Okay. I will do my best in 6th period to try to do different examples from what you guys did. So if you want to watch it, you can. If not, then that's fine. I'll be here after school until 5 tomorrow.
Is this your lunch?
Is it y'all like he's writing that? It is funny, but